Now that you have your obtained t-value of 2.70 absolute value, or in your case negative 2.70, we need to compare this to our critical t, which is 2.00, and determine, do we have a statistically significant difference? Well, of course, as you all know by now, when the obtained t-value exceeds the t-critical value in absolute terms, in other words, regardless of the plus or the minus sign, if 2.70 is a greater value than 2.00, then you have a statistically significant result. So this test has returned a statistically significant result, and you can state that in symbols in the following way. Reject HO, T, parentheses 78, and what is 78 here? Of course, that's your degrees of freedom, right? So you're telling the degrees of freedom that this T is referring to. Now, the value of this for the reader is that if the reader is reading this, any reader can now go to the t-distribution table that you use to identify your critical value and confirm that, in fact, for a sample with degrees of freedom of 78, 2.70 in fact exceeds the critical value of 2.0, and this is a probability less than 0.05, right? But now you all know you cannot stop here. This is only telling you the probability of getting this amount of difference, the amount of observed difference between groups, by chance alone. And you have to do an effect size test to find out how large the difference is between your groups. And that is the size of the effect that you've observed. Now, the effect size formula, of course, is different for different types of tests, but only slightly so. The numerator is still mean 1 minus mean 2, so you're subtracting two different means, and the denominator is where you see the difference. Now, you should recognize this denominator. It's sum of squares 1 plus sum of squares 2 divided by n1, the sample size from group 1, plus the sample size from group 2 minus 2. That's your degrees of freedom, right? And notice this is the same denominator as what we had for determining the standard error of the difference between sample means without the correction factor of 1 over 40 plus 1 over 40. So knowing that, if you hand calculate a t-test again, you could just hold on to this value as you're calculating through your other one. But since we didn't anticipate that, let's go ahead and, for practice, calculate this through. So in this case, we're going to have mean 1, absolute value of mean 1, and we know the mean value for the group 1 is 17 minus 21, and that's divided by the square root of 1440 plus 1960 divided by 78, our degrees of freedom, right? 40 plus 40 is 80, minus 2 is 78. And we know that when you calculate this through, this is 3,400 divided by 78. We've already done that. And if you take the calculator and you do 3,400 divided by 78, you get 43. We'll continue this over here. Square root of 43.59. And that square root is 6.60. So 6.60 is your denominator for this effect size measure. So let's just copy that over here. And we know that 17 minus 21 absolute value is 4 over 6.60. So let's do 4 divided by 6.6. And we get 0.61. So in this example, your effect size is 0.61. That's one of the largest effect sizes we've observed in any of the examples. That's considered a moderate effect size. Now you should proceed to do your second evaluation of your result, which is calculating the confidence interval to determine the precision of the difference that you've identified.